Welcome everyone to the PDPro software platform for partial discharge testing webinar. My name is Lorenzo Paschini. I'm a senior service engineer at Techimp Altanova Group. What will be the summary that we're going to talk about into this webinar? We're going to introduce the PDPro and the compatibility of this software with the existing and future instruments. We're going to talk how the PDPro is designed to be used with different assets to be tested. We will explain how the PDPro database can be built and what are the advantages of such a database. We will introduce the Techimp Altanova patent time frequency map tool. And then we will start to check what are the different acquisition modes those can be found on PDPro. In the end, there will be a short introduction about the new features introduced with the latest version of the PDPro, the 2.0.0. Those are mainly focusing on the test plan section. So, first, what are the characteristics that a software for PD testing should have to make the asset manager life easier? You should have a good data management system. You should have a standardized test procedure. You should create homogeneous data. And we should be able to compare results and trending. We need one single platform for different users. So, testing team, data management team, and data analysts and decision makers will work all on the same platform, that is the PDPro. Our input for the PDPro will be information and knowledge, and our output will be decision and risk reduction or risk mitigation. The PDPro is the new software for Techimp that is able to be used with all the past and current testing instruments from Techimp. So we can use it with Aquila and Micro Aquila, the portable PD instrument. We can use it with the PD scope. Those are the key acquisition unit of high voltage asset PD monitoring as well as rotating machine PD monitoring. We can use it as well with the laboratory testing unit, the PDBase2, used for EAC 60270 testing for PWM and type testing of insulation material. We can use as well the PDPro with the Falcon, that is the medium voltage standalone PD monitoring, and with the PD check, that is the first generation of our instrument for PD testing and monitoring. Next generation testing equipment will be also using the PDPro software. So, if some of you have some experience about the Techimp instruments and software, they know that there are several software. Those are used with the different equipment and at different stages of the data analysis and data acquisition. There is the PDBase standard, that is the software to acquire PD test in the laboratory with PDBase2. There is the PD check control, the software used to acquire data with the portable units or with the PD check first generation. And then we have the PD processing, that is the universal analysis software, and the Teams and T-SCADA, so our monitoring systems. Those create a large amount of PD data, those can be analyzed. All this data can be saved into our new DB of the PDPro. So we can include all the previous acquired data on the older software version in the new PDPro database. Where we can use PDPro? We can use the PDPro in all the portion of the testing. So the first step of an asset is always a laboratory testing. So we can use the PDPro with the PDBase2 for quality control purposes when we have to make factory acceptance test or end-of-line testing for partial discharge measurement. We can use as well the PDPro for the commissioning of high voltage equipment or for online spot measurement on high voltage equipment or medium voltage equipment with the Aquila or Micro Aquila. And we can use the PDPro to analyze the data coming from the permanent monitoring. Those can be T-SCADA or Falcon. One software for all the different stages of the lifetime of an asset. Let's take a look now at the PDPro database. So we will see how the DB can be created and how we can manage the data into the DB. First of all, we need to create a census for the registry. So every asset will have its own identification into the DB. We can build its, let's say, identity card, and all the current and future acquisition can be linked to its registry that is unique for each detection point. Then we have the asset book. So once we have a DB, we can browse into the registry that we have created in the past to retrieve PD acquisition or to start new PD session and save new PD data. We can also browse the existing data with the acquisition browser, and we can include and we can use this function also to include all the data to the registry. And last but not less important, we can have in our DB a series of test plan standardized that we can recall to run standardized tests whenever it's required. How to create a new registry? Basically, we assign a unique identification number to the registry, and we will add to this registry few information like the customer of the test, the name of the circuit or asset, the location of the asset, rated voltage, the serial number of the apparatus, the manufacturer, and the vintage. We can decide, we can introduce all the different detection points depending on the asset. If you see on the asset type menu, we can select cable, GIS, rotating machine, switchgear, and transformer. For instance, to make a too short example, if we create a registry for a HV cable, three-phase HV cable with two termination and two joints, those are accessible and then we can test. We can create a registry with a total number of 4 detection points per phase, so 12 detection points. Those will be always the container of the PD data related to the asset, the detection point. If we have, for instance, a rotating machine, normally we will have just 3 phases to be tested, so we will have 3 detection points, 1 for each phase. And same way as for the cable, we will create these containers where all the PD data will be stored from today to the future session, and we can also include the older data in the same registries. You see here it is the phase choice. We can select what are the phase number 1 or 3, and the phase name. So we can have U, VW, RST, red, yellow, blue. And we can also add a certain number of detection points. 1 point in case of the generator, where we have just 1 detection point. A different number of detection points in case of distributed assets like cables or GIS. Now we have a short video how to create a registry with an example. We fill the customer name. We fill the circuit or asset name. In this case, I put hydropower plant. Just let's say dummy names without specific let's say identification. We place the location Zola Predosa, with this Techimp HQ location, rated voltage of the asset, serial number, manufacturer, vintage, and we select, for instance, rotating machine. So we have chance to select how many phases we're going to have in our registry and what will be their name: red, yellow, and blue. And how many detection points do we have? Here we create 2 dummy detection points, 1 for machine and 1 for system. We can put the voltage type, the machine typology. Oh, typo. And the registry is now saved. So with just a few clicks and digits, we have created a map where we can save the data related to the specific asset. Then we have the function and the DB to query a registry. So we can retrieve an existing registry using filters that you can find on the menu on the top of the window. Those where we will see on the list the registry ID, the customer name, the circuit name, the location, and the apparatus serial number. On the registry will be shown the details introduced during the registry creation and can be copied, modified, deleted. We can run an acquisition, or we can import data from this point. Here we have the filter function. You see we have a series of fields that we can use, like the registry ID, the customer, the asset type, the location, or we can also select more filters if such information have been introduced during the registry creation. The first four are mandatory, so they're always present. Data import. So as I told you before, we can import all the PD data from Techimp system in the new registry just by selecting with the query registry the detection point of the related PD data. And by clicking the import acquisition file, we can import all the previous PD acquisition in the new DB, and they will be visualized in the new PDPro software. Open dataset, query registry. We will add the PD test details. Those were not, let's say, details introduced in the old PD data, like the phase, the detection point name, the PD sensor used, the synchronization sensor used, and the type of PD test. It can be offline, online, and so on. All this information will be then used on the DB if we want to browse a certain kind of detection point or PD sensor used, and so on. The function of the DB to query acquisition is to, let's say, find the previous acquisition that will be displayed just for the PRPD NTF map to have a quick overview, and that can be then further studied with the processing tab. And with this very, let's say, straightforward approach, we can find quickly an acquisition from our DB related to a past test. Even in this case, we can use the filters function that you can see on the top of the window to browse the DB for a customer name or for a location name, for asset typology, and all the details those have been introduced in the DB registry. To query a test plan, we will have the list of the test plan those have been created on the PDPro, and we can retrieve one of the test plan to be run for a new test or to be modified. I want to be quite clear on this point because we have made a lot of effort to improve the test plan function. Let's say that the test plan target is to create a structure of tests that can be easily recalled and run by even non-expert users, and that will give automatically a good data set to be analyzed or to be compared with older data set. So we'll have less parameter controlled by the user, so will be much more automatic, and the output of such PD testing campaign will be more easier to compare with older data set performed with the same test plan. Let's take a look now at the time frequency mapping, the Techimp patented technology for PD, let's say, separation and filtration. The PD pulse is always a current or voltage pulse that is resulting from a partial discharge. It can be coming from the test object or can be due to external disturbances or external discharges occurring in the site or in the laboratory. Each PD pulse is characterized by its own waveform. The waveform that we see on the right is a PD pulse. 10 microsecond sample PD pulse. Sorry, 1 microsecond sample PD pulse. And there's a lot of characteristics of, let's say, shape, frequency component, length of the pulse. But normally what is done by most of the, say, detector as the first thing is to acquire the peak of the pulse. The peak out of the pulse together that can be measured then in millivolt or in picocoulomb, depending on the application and the technology, will be displayed in what is normally called the phase resolve PD pattern, where the pulse is plotted related to the applied voltage phase angle. And in normal condition, that's all the information that we get out from this PD pulse. We don't, let's say, take into account the pulse shape or the pulse characteristics, the frequency component, and so on. So amplitude and phase, for every second, we have a PD instrument that acquires thousands of these pulses and gives a series of amplitude values and phase angle to plot the PD pulse. All the pulse shape is hard to be managed. We cannot, let's say, watch one by one all the waveform, but we know that the frequency signals can be studied, the high frequency pulses can be studied as per their frequency component or for time duration of the pulse and so on, to characterize the PD pulse from another point of view of the amplitude. We can have, for example, the frequency spectrum. The Techimp technology has the characteristic to extract from the PD pulse not just the amplitude of the pulse, but also two numbers of equivalent time length and equivalent frequencies. Those are statistical parameters. Those can be used to manage the data in a different way. Once we have the characteristic of the pulse in terms of frequency component and shape translated into numbers, we can do many things with these numbers, because we can compute the pulses with the rules following these numbers. I can decide, for instance, to manage, to filter, or to save the data based on this frequency component. The typical display of the PD pulse is then not just pure PD, when we have amplitude on the vertical axis and phase angle on the horizontal axis, but also time frequency mapping, when we have equivalent time on the vertical axis and equivalent frequency on the horizontal axis. This double point of view gives us the chance to decide to filter out a portion of this time frequency map, to clean the related pure PD pattern, or to separate the component of the time frequency map, the different cluster, to study the cluster of pulses one by one. Obviously, different PD pulses will have different characteristic values of equivalent frequency and equivalent time length, so we can separate the PD sources digitally thanks to the TF mapping technology. Let's take a look now at the in a very practical way the PDPro acquisition modes that we have. When we launch the acquisition function on the PDPro, we have chance to select, depending on the license, 4 different modes of acquisition: base mode, test plan, advanced mode, and operator mode. Let's start discussing about the base mode. The base mode is a very simplified acquisition procedure. The software, without any input, just decides the acquisition parameters to be used based on the stream of the PD signals connected to the instrument. And this is the only, let's say, the only way to have a completely automatic PD data just by pushing one button. That is that play button on the top left, on the bottom left. So without effort, without knowledge, we can connect our sensor to the instrument, our software to the instrument, and launch an automatic acquisition. Obviously, the quality is automatic. It's not as good as an acquisition made by skilled operator. We have no chance to take full advantage of the filtering tool, but it's a very cost-effective and easy way to get PD data. The advanced mode, together with the operator mode, are oriented to a more skilled operator that wants to have control over many of the parameters that we can have during a PD acquisition. The advanced mode is strongly oriented to a 3-phase acquisition. If you see, we have 3 rows. Each row corresponds to a channel of the PD acquisition unit, and the PD data will stream on the 3 rows simultaneously. On the top right of the window, we also have a waveform pulse streaming related to the three different acquisition. From the advanced mode, we can select also the acquisition parameters like full scale, trigger, and phase shift, together with the time length duration of the analyzed pulse and with the duration of the acquisition. So there are many more things that we can do, the operator can do and select during the acquisition. It is also possible to use time frequency map technology by right-clicking on the TF map. We can select an area to be filtered out or in the acquisition, and it will be displayed together with the other two during the streaming. The operator mode is, let's say, a more single detection point oriented software, so we can work channel by channel. In this case, just one channel is visualized, and we have also a chance to, before acquiring data, to have a pre-processing acquisition just by clicking the camera button here on top. We will have a screenshot, an instantaneous picture of what is the data stream, and we will be able to select a portion of the TF map to visualize what are the pulses related in the PRPD just on the left of that. It is the, let's say, classical approach of the Techimp instrument, so you can consider the bottom side of this window as a dashboard to take full advantage of the time frequency map technologies. We can easily check what is the PRPD pattern related to a subgroup of the TF map, and we can decide if we want to keep that data or if we want to discard that data. Even here, we can select a full-scale trigger and threshold and phase shift, sorry, together with the pulse duration, duration of the acquisition, and so on. By moving to the different channels, it will be possible to select the different channels of the instrument in case we are doing a three-phase measurement. Here on the top left, you can see the channel menu. Now, there is no mention here of the test plan because test plan will be discussed later on extensively. Let's take a look now at the PD processing function. The PD processing functions of the PDPro are the ones related to the data analysis. So we already have our stored data in the DB. Whenever we want, we can recall the data and study that data. This is the home page of the processing. So normally we have three possible rows where we can load a series of data. Why three? Because normally we want to have the three-phase measurement all in the same window to make comparison and study crosstalk or reflection of the signal from one phase to another. There is a chance to change the visualization of the data in the full-scale base or in the phase shift base, so that we can play with these parameters to check the correspondence with different phases signals. This is a very easy visualization. We have the number of, let's say, acquisition on the column of the right. We have some information of the acquisition on the column on the, sorry, on the acquisition are on the column on the left. And the information regarding the acquisition are on the column on the right. We have, for example, the Qmax value, the maximum amplitude, the trigger value, the repetition rate, the date, and the bandwidth used for this measurement. If we want to have a deeper study of the single acquisition, by clicking the process button on the top of each row, we can have a pop-up window for with advanced processing functions. In the advanced processing, we have different tools that can be used to analyze and clean the data. The page that we see right here is the home page. So we have the full scale, the PRPD pattern, and the TF map. And in case we have performed a waveform acquisition, we also have the visualization of the single PD pulse and its pulse spectrum. The series of logos on the top left that you see are the different stages that we can use to study our data more deeply. So the advanced home page is the one that we have just seen, where we see the PRPD pattern, the TF map, and we can visualize the PD pulse and their pulse spectrum. Then we have the separation tab, that is the tab of the processing where we can work with time frequency mapping separations. we have a PRPD pattern filter. We can clean the PRPD on the polarity phase angle base, so we can decide to clean the acquisition from sporadic points. Those are falling outside the expected phase angle and amplitude position. We also have the identification tab. There is the fuzzy logic identifying the PD nature. There's a first stage when we just make analysis for the kind of macro families of PD, so internal surface and corona or noise. And we have also a second stage of this analysis, depending on the license, where we can associate the statistically associate the PRPD pattern to the effect typical of the asset under test. So we have to define if it is a cable or the machine, and the system will try to correlate the current data with one of the typical defect that we can have in such assets. Then we have the TDR tab, the time domain reflectometry tab, used for pinpointing PD in cables. We can use this tab typically to localize PD along a cable system. And we also have a PRPD pattern movie tab, where we have chance to just replay the acquisition at a slower velocity in order to understand the nature of some phenomena that can be sporadic or intermittent. And we also have the trending tab, where the PDPro will plot down all the acquisition related to the registry on the basis of the amplitude or repetition rate. Let's take a look at them one by one. Advanced home page is the one that we've seen. We have PRPD pattern, TF map, eventually PD pulse and its pulse spectrum. Separation tab, we have chance to create different cluster of points on the TF map by selecting different colors, and we can, by applying this map, we can create the related sub-pattern to study the PD phenomena occurring in the asset one by one, or to separate the noise from the phenomena. Then we have the PRPD pattern filter. So in this case, this was the input with some points. Those were fallen outside of the expected points, and we can just remove them by focusing the attention on the colored portion of the PRPD, and the output will be a more clean PRPD pattern, easier to study. Identification tab, as we have mentioned before, give us a generic identification with the corona surface internal or noise not identified in the asset, not identified the SPD in the asset, and there is also the likelihood counter. So in this case, the system is very sure that the acquired data is a corona discharge. There are also some of the diagnostic index parameters listed here, like Qmax, Qmin, pulse per second, pulse per cycle, and so on. We can see also the other tab of the pattern movie. We have a very simple video that shows how it's like to take a look at the pattern movie. If you see, there is also a cursor on the right of the tab, and we can increase or decrease the velocity of the replay. This function is very useful if the data, for example, was not, let's say, taken by a specialist, but the specialist would like to have the same visualization that was running during the test. Very good to have. Time domain reflectometry. It's a system to pinpoint the PD pulse. The operator will recognize on the waveform the peaks related to reflections of the PD, and by placing the cursor and the length of the cable tested, the related PD source will be pinpointed on the bottom. There is also a chance to clean a little bit the waveforms from let's say, unwanted frequency component. We can clean lower portion of or higher portion of the frequency bandwidth to clean the PD pulse and have a more easy to recognize peaks. Last but not least, the trending tab. So for each detection point, we can plot the trending tab, we can see here we have the time, and we have different values here. We can plot Qmax, repetition rate, pulse number, sync voltage, and by clicking on the single point, the related PRPD pattern TF map will be visualized. So let's take a look now at an example of the PDPro without talking about the test plan, because test plan will be extensively discussed later on. So this is an example of operator mode acquisition with post-processing and automatic report. So we connect to our unit, we select the channel, and we have the data stream. The operator can move the full scale and trigger parameter to obtain optimized visualization of the PD pulse. We can see that we have pulse is saturating the full scale. There is the saturation indicator on. So we can keep changing full scale and trigger to have an optimized value. And we can decide to eventually save the data. It is now created. We can check the related TF map portion on the dashboard below. And as you have seen, whenever we select an area, the related sub-PRPD pattern is shown. We can then decide to acquire. We have to put a few information for the DB, so which phase are we testing, what is the detection point number, and which sensor are we using. We have now created an acquisition that you can see on the acquisition log. We can recall this acquisition, and by pushing the processing, we can already start to watch the data analysis of the same acquisition very quickly. Just with a few clicks, we are already in the PD processing tab. We can create time frequency areas, separating two different cluster of points, in this case, red cluster and blue cluster. We can decide to apply PRPD patterning filter. And we can decide also to check the different identification for the three clusters created: black, red, and blue. In this case, we had a corona discharge for the red cluster and a surface/internal discharge for the blue cluster. By creating a report, the software will give us a Word file including the information from the detection point, the full PRPD pattern and TF map, the classification of the TF map, and the study of the single cluster created with the TF map classification, with their identification and characteristics of the PRPD pattern analysis. With a very few clicks, we have run from the acquisition down to the automatic report. Instead, in the following video, we are going to show the advanced mode simultaneous acquisition, so not the operator mode, but the advanced mode, with the PD processing tool and configuration. Let's take a look. We create a new registry, including the customer, the asset type, the location, the vintage, from 0. So we are now, for example, starting a new acquisition just at site in front of the asset we are testing. We create our registry. We define all the characteristics. We define what we are testing, in this case a GIS. We call the phases we are testing. We identify how many detection points we want to register. We number them, for example, we can put different names. And now this registry is created. We can then run the acquisition. We retrieve the registry from the DB. And we run the acquisition. In this case, we are going to use the Aquila with the advanced mode. The PDPro is now ready to acquire data on that particular registry of the DB. Here we have the three phases running simultaneously. we can move, you see the full scale and the trigger one by one to optimize the data acquisition. Here we are always talking about, with advanced and operator mode, we are always talking about, let's say, skilled operator, those who want to have everything in control. Then we assign each of the channel to one detection point and put some test information for channel 1, channel 2, and channel 3. And this can be done by the chain button that you have seen right now pushed by the operator. And now all the channels are correlated to with registry with all the information about the sensor used, the asset type, and so on. And we are ready to launch an acquisition. We have just launched a simultaneous acquisition on all 3 channels with the acquisition timeout 10 seconds, max pulse number 10,000 pulses per channel. And as long as the acquisition is finished, we have created the 3 acquisitions that you can see in the acquisition log. And those ones are already set in the DB and they can be studied with the PD processing already, just by selecting all of them and launching the PD processing full. Here we can run the same analysis run before. We can run the PD pattern movie, like in this case where the velocity has been changed. And I guess that is over. Yes. Now, as I've mentioned before, the newest thing that we can, the newest tool that we can find on the PDPro 2.0.0 are the new test plan function. So the test plan was originally designed to be used for routine tests, like end-of-line tests in the factories, where we have to repeat the same test on all the assets of a certain family with the same testing condition. The new test plan has widened a little bit the field, and it is also, let's say, editable in order to be used for on-site testing, because we can manage different aspects of the acquisition, and we can take advantage of the auto-set functions of the PDPro also for site testing. Let's make an example of the typical application of end-of-line testing. We are a resin cast transformer manufacturer. We have 3 main products, typology, A, B, and C. Each one of this family, they have a standard test. So all the product of A shall be tested at this voltage level with this acceptance criteria. The B family has different voltage levels and different acceptance criteria, and the C has another set of voltage level and acceptance criteria. Here we have an example that I've invented just for a structure to follow. So, for example, family A has a 3-phase, so we have to measure 3 channels at 3 different voltage steps with related acceptance criteria of 2 picocoulomb, 5 picocoulomb, and 10 picocoulomb, while family B is always a 3-phase asset, but the voltage step is there are just 2, so we only have to test at 2 steps with 2 acceptance criteria. And the type C is a single-phase transformer with a different voltage step for the test and a different PD acceptance criteria. So for each transformer, we will have a standard test. Whatever product of the family A will always be following 3 steps with those acceptance criteria. Same thing for B and C. So what we will need to make something more automatic. For each transformer, the operator will create a master registry. So we will have a transformer information family, like this is the type of transformer A, is a resin cast, has got 3 detection points, and so on. Then we will create a test plan that is designed to follow the voltage steps and the PD acceptance criteria. Those are standardized for this family. and eventually a calibration file that we can load if you want to run ESE 60270 test. So since we are testing always the same asset, if we want, we can have a standard calibration to be run all the time without injecting the pulse all the time, if it is a standard, let's say, standardized equipment. So what will be the workflow? The operator recall which test plan to be used depending of the type of transformer he has to test. So we will have A, B, or C. I have the test plan for A, test plan for B, and test plan for C. I recall the one for A. I run my test. The acquisition is automatically made by the software. The software automatically compares the result with the threshold that we have to follow, and we have the acquisition, the result, and a PDPro report containing a pass, false, and so, and all the information about this transformer. And this transformer is a registry in the DB. There will be many others like him, but not exactly the same. We can have, for example, different serial number. We can decide to modify the serial number each time. And whenever we start again, say, okay, we have finished the test on this transformer, let's run another one. The system will start from zero. We'll ask, okay, we are doing the same family. What is the serial number of the transformer you want to test? And again and again, this very quick test can be continually going on for the working day, and we will create a standardized set of values, standardized data report based on a standardized test plan. This was the application for the end-of-line test. So we have a test plan to be followed and homogeneous result, homogeneous practice to run the same test many times on similar assets. Let's make a new example for the test plan. Transmission distribution utility as well as industrial plants, they have a huge population of many assets. They can be cable, motors, transformer, and if they want to have, let's say, a standardized analysis of such assets, they need to have a standardized way of testing them. Normally, it is possible to indicate like a series of typical layouts, typical asset layouts. Those are present in our distribution network or in our industrial network. And we can build a test plan related for this family of tests. They can be, for example, test plan for 20 kV able termination of cables, or 6.6 motors like family B, or 15 kV transformers. And we can standardize a test plan for this test. In this case, we will have an operator that goes in front of the asset to be tested as some instruction to install the sensor, recall the acquisition test plan. The PDPro, following the rules listed in the test plan, makes an automatic acquisition composed by voltage steps and so on. So we have the data. We have now all the data comparable in the DB, and we can give to analyst or specialist the good data taken from the different assets in a very homogeneous way to be analyzed and studied. So in this case, we use the test plan not as an end-of-line test, but to standardize the online testing and to have a tool to perform good quality PD test without being a specialist. Then we will have a homogeneous data set where we can see the differences between healthy and poor assets, and this data can be or studied by the same operator that performed the measurement, or studied by a specialist that is, let's say, staying in the office with 1, 2, or 3 testing crews. Those are going around and taking the data thanks to the test plan. Now, let's take a look at what can we do with the test plan. So we will have the test plan editor, where we can create the test plan, really create the test plan. So we'll have first the test plan details on top, then we have the measurement plan details, the registry field, those we will have to set, and additional test plan keys if you want. Let's look what are the test plan details. The operator should set a name. For example, we can create a test plan for the transformer A family. We can put it as a name, transformer A. We have to select if we need a ESC 60270 acquisition or not. We have to select which acquisition unit we are using in the Techimp family, obviously. And we also have a chance to select if we want to run consecutive channels. So we just push acquire on the system, and if the acquisition shall be made in 3 channels, it will automatically go from 1 to 3 without asking anything to the operator. And if you want to ask for registry, this second function is basically created because suppose that we want to run a test to the series of transformer family A. We have to create the registry for each transformer of the family A, but what will change will be maybe just the serial number. So I want to create automatically the registry. I will ask to the test plan every time I start, ask me for creating a new registry where I will decide the new serial number or new, let's say, characteristic to be put in the registry in the DB. Then we have the measurement plan details. So we will have typically steps. So we will have a step name, the applied voltage and the acceptance threshold that we have for that step. Then we can select acquisition parameters that we want to have, like time length and the time. Also timeout and max pulse number. Those are typically the 2 key parameters to define the acquisition duration. And if you want, we can put some additional notes about the step. If you want to add another step, we can add another one just by pushing on this plus button on the top, on the bottom right. And we can have a second step that can be characterized by different voltage step or different threshold or different time length. Why not? And we can go on like that to build the test that we want to have. Typically, we can do the same test with different time lengths, or we can have the same time lengths at 3 different voltage steps. This is all things that we can change, and they are up to the user. The second portion is the channel management. Here we define how many channels we want to use, 1, 2, 3, up to 7, depending on our equipment and how if we have a multiplexer or not. If we want to have if we want to use a pre-existing calibration for the ESC from one of the ones saved in the DB, what will be the phase shift and the synchronization ratio to be used? In case of PD base, we will use the sync ratio. In case of PD check, there is not this function because it's not for laboratory normally. And we also have for the PD base the possibility to select the sync source, the full scale of the sync, the time length of the sync, and the depth of the sync. More laboratory oriented. In the end, we have the registry field to be set. So if we want to the software to create for us a new registry for each run of the test plan, we have to define to the test plan which registry we want to change all the time. For example, we can decide to have serial, different serial number, or we can also have additional test plan key to add, like operator name and so on, that will be saved together in the DB. Let's take a look at how we can create a new test plan with the editor. So we have a new window of test for the test plan. We can select the name. We can decide to have it ESC or not. So if you see that if we select ESC, the readings, the threshold will be in picocoulomb. We have chance to load the calibration. Everything changes a little bit. Then we can define which device we're going to use. all the Techimp devices. We can select if we want to have consecutive channels or not, and we can select if we want to have ask for registry. We can modify the step name, just call it test 1. We can define what will be the applied voltage for the test 1. We can define what is the warning threshold for this test. In this case, I'm working not in AAC, so I put, let's make a test with a 20 millivolt threshold. I keep the 2 microsecond of the time length. I select a longer timeout, 30 seconds. I select now a master registry to be used, where I will decide to change the serial number every time. My measurement will be a single channel. My phase shift will be 0. I don't select anything here on the synchronization to have an applied voltage, just because it was not, I was using an unknown divider. I can put an additional test plan key like operator, so the system will ask every test which operator is doing this test, and will save this information as well. And now I have my test plan ready to be used. In a few clicks, I've created a test plan that can be run by the system. Let's go for the real acquisition then. From the home page of the PDPro, I can query the test plan. I can have the test plan list, and I can decide which one to use. The first window when I start will be the additional key that I put on the test plan to be saved. And then I will have already my window of the test plan acquisition, where I have all the step parameters selected during the test plan editor stage. I have the channel parameter, and here I have to fill the fields required by the test planning. For example, here I put that I have to insert not just the serial number, but also the asset name and the location. Here there is an example, so depending on the test plan, one or more fields can be filled. Here I have to fill all of these 3 fields. Once I have filled properly these 3 fields, I have chance to go on and create a new registry that will be used to save the data. This is the final result that I have. Then we have also video. In this case, I have 3 measurement channels, so I have defined I had 3 different channels with 3 different acquisition. I had a threshold of 0.02. In 2 cases, my acquisition was higher than the threshold, and the result automatically is given as a faulty by my system. So when I'm closing the acquisition, the system is saying, look, you have failed your acquisition as per the test plan specification. Put a comment and save the data. Let's see now a video of the process. So I recall one of the existing test lab. I run it. I already have the query saved, so I don't have to save it together with anything else. I have to put the operator name as set during the test plan editor. Otherwise, the system won't let me start. So I want this information to be saved. I can connect to my instrument. Once I connect, I also have few information like if I'm synchronized, if I have a good connection. So the operator, even without being an expert, can understand if the system is ready to start. I have to set a new serial number. So I give the OK. I create the new registry for this serial number. I have chance now to start my test. Phase A is OK. I'm using a sensor that is in this case 1 nanofarad capacitive coupler. Sync is from the divider, and the PD test is offline. Everything is ready. I run now my test. The PDPro starts to see this data stream, optimizes the value of full scale and trigger to have a fast and quick acquisition for this single voltage step, defines what are the output. In this case, my Qmax was higher than the warning threshold, So my result is not passed. I can finish the test. The system is suggesting that the test is failed. I put a comment. I save the comment together with the test. The test one becomes red, and I can create a report about the result of the test plan, where I have in a couple of pages the information about what I've just done, and I can look back and find what was okay and what was not okay in the doc file. Now the report is saved. I can open the doc file. Where I have a resume of the acquisition of the applied voltage to my applied voltage profile. I have a resume of the Qmax measure, the warning threshold that I have. There is the test result. And in a few seconds, I performed a very quick test result. So the key point of these new features introduced in the 2.00 is to have a guided way to perform good PD acquisition even without being an expert. This is something that we have decided after we have seen in the market that many times the PD tests are carried out not every day. So it may be possible that in a couple of months we do the acquisition slightly different from what you have done the first time. And this will affect the result and the data comparison. By taking advantage of pre-existing test plans, we can run good testing and we can have good data to be studied and compared a long time or between different assets. This was the last slide of our presentation. Thank you so much for your attention, and I hope to hear from you soon, and I hope you have also enjoyed this webinar.